Hi, my dears. In this session, we will be discussing on the image formation by convex lenses using ray diagrams. So, this is a convex lens. We discussed already when the object is at infinity, the rays will be parallel to the principal axis. As it passes through the convex lens, it will get refracted and all the parallel rays that are parallel to the principal axis will be going through the focus. So here they will be, this is a convex lens, so it will be a converging lens. It will converge the parallel light rays and they will join at the focus when the object is at infinity. So the image is formed at focus. It is, if you see, it's a point-sized image. So it's a highly diminished or point-sized image, and it is a real and inverted image. In convex lenses, you will be able to make the comparison easily between the concave mirror. So for your to recollect things, it is easier if you compare and study convex lens with concave mirror. And also, in the case of a convex lens, remember your real and inverted images will be formed on the right-hand side of the lens, while in the concave mirror, it is on the left-hand side. Okay, so always for a ray diagram, we will be following exactly the Cartesian sign convention. So whenever you draw a ray diagram, it should follow that the light source will be coming from the left-hand side of the lens or a mirror. In both the cases, we will be following drawing a ray diagram with the object and the left-hand side. And now the second case, when the object is beyond 2f. When the object is beyond 2f, the parallel ray that will go and hit the concave lens, a convex lens, will get refracted and will go through the focus. While this ray that goes through the optic center will not suffer any deviation. If you see, these two light rays will meet at this particular point where you have your B prime, A prime or your image, and you notice the image, it is a real and inverted image. It is formed in between the focus and the center of curvature, and it is a diminished in a small image. It's real and inverted. When the object is placed at 2f1 or the surface center of curvature, the parallel ray will go through the focus and will extend the ray here. The second ray that goes through the optic center will meet at this particular point where you have your B prime, A prime or the real and inverted image. The characteristic of this image will be, it is of a same size. It is formed at the center of the second center of curvature or 2f2, and it is a real and inverted image. Here, you remember in concave lens, just when you had the image object at C, the image was also formed at C. So this is all the same. The object is kept at C, the C1, the image is also formed at the center of curvature, but the second center of curvature. And it's of the same size. Well, and now when the object is placed in between 2f1 and f1, the parallel ray will go through the focus, extends it up till here. The second ray that goes through the optic center, these two rays join up here, and you see the B prime, E prime is a real and inverted and an enlarged image. It is formed beyond 2f2, which is the next set. It is formed beyond 2f2, the center of curvature, and it is an enlarged and real and inverted image. So when the object is at infinity and beyond 2f, you had a small image or real and inverted but yet small image. At 2f1, you got the same size image, and the moving forward from 2f1 to the optic center, you will have enlarged images. Okay, that will be your pattern of the image. And when the object is placed at focus, see the two light rays, that the first one will be going through the parallel, will go through the focus. The second one going through the optic center forms these. If you look at the characteristic of these two rays, these are parallel rays. These parallel rays will never meet, but in optics we say the parallel rays will meet at infinity, forming a real inverted and an infinitely large image at infinity. Okay, so it's just the opposite. When the object was at infinity, the image was formed at the focus. And so when you keep the image at focus, you have the, you keep the object at focus, you have the image at infinity. So it's just the opposite. And now the last case, when the object is in between F1, that is a focal point, the focus and the optic center. When the object is placed in between the F1 and O, the parallel ray will undergo refraction and will go through the focus, while the ray going through the optic center will not suffer any deviation. If you see these two light rays, they are diverging light rays, and we know diverging light rays can never meet. So we will extend these two rays, and these two rays appear to come from this particular, that is, an image is formed behind, that is from on the same side of the object. You get an enlarged and a erect virtual image. So if you notice this image, it is on the same side of the lens as the object. It is an enlarged image, it is virtual and erect. So convex lens will give you virtual and erect image only when the object is placed in between the focus and the optic center. All the other cases, you will have that you have six cases where you have all your 5 cases. The image is formed are real and inverted, and it is always on the right hand side. But in this case, you will have a virtual and erect image, and it is the image is formed on the left hand side. Okay, it's a word. And now this is a summary of the same that we discussed, which is there in your NCERT textbook. And now the image formation by concave lenses using ray diagrams. When the object is placed at infinity, in the case of a concave lens, it will go hit the concave lens, and the concave lens is a diverging lens. So what happens is it will diverge the light rays, and it will all these rays will be getting diverged. But these diverging light rays will appear to come from the focus, and here you have the image which is formed, and the image is formed at focus. It's a highly diminished and point-sized image, but it's a virtual and erect image. When the object is placed in between the infinity and the optic center, then you have the parallel ray going and hitting the lens and getting diverged. And here the ray that is passing through the optic center will go like this. So if you extend this diverging ray, these two rays will meet at this particular point where you have your B prime, A prime, and see it is a virtual and erect image. It is formed in between the focus and the optic center. It's also it's a small image, right? So it's a diminished or a small image. It's a virtual and erect image. Remember, concave lenses will only give you virtual and erect images. And yeah, that's it. And we will discuss this is also given in your NCERT textbook. It's a summary of what we discussed just now. The Cartesian sign convention holds true for the lenses also. So the lenses, you have your x-axis. The positive x-axis will be positive. That is, everything in the case of a convex lens from O to 2F2 will be positive. And anything on above the axis, that is positive y-axis, will also be positive. The negative x and the negative y-axis will be negative. Remember, the convex lens will have a focal length which is always positive, because in the case of a convex lens, you have the focus on this side. So you get your focal length always positive. OF2 will be always positive. While in the case of a concave lens, you will have the focal length as negative. So dears, thank you for your attention.